Hello students, today we're going to take session 3 of our lesson which is real numbers. This is for grade 9, it's teacher Sarah. Today we're going to talk about powers of 10, scientific notations and solve some applications. So starting with powers of 10. When we say powers of 10, we mean these numbers are of powers of base 10 or powers with base 10. Example, 10 squared, 10 cubed, 10 to the power 5, and so on. Let's take examples. 10 to the power 1, 10 power 2, 10 power 3, 10 to the power 4, and 10 to the power 5. If I want to find the answer, it means 1 with 1 0. Here, put 1 with 2 zeros. 10 squared, it means 10 times 10, which is 100. 10 cubed, 10 times 10 times 10, which is 1000. 10 to the power 4, it's 10,000, or you put 1 and 4 zeros. Here we put 1 and 5 zeros. But if we have negative exponents like 10 to the power minus 1, 10 power minus 2, and 10 power minus 3, we said before we change the negative exponents into positive exponents by changing this number from numerator to denominator or vice versa, writing its reciprocal. 10 to the power minus 1, it means 1 over 10 to the power 1. Now it becomes a positive exponent. Okay, so 1 over 10, it's equal to 0.1. You can change 10 to the power minus 1 into 1 over 10, then write it as 0.1, or directly when you see minus 1, it means tenth. Okay, so 0.1. Similarly, for 10 minus 2 and 10 minus 3, so 10 minus 2, it's 1 over 100, which is equal to 0.01. Or directly, 10 minus 2, it's 100th. 10 power minus 3, it's 1000th. 0.001. Now let's talk about introduction to scientific notation. Scientific notation is a way of expressing very large or very small numbers in a compact and convenient form. So it is used in various fields like science, engineering, and technology. Why do we need scientific notation? We need scientific notation for very large numbers and for very small numbers. For large numbers, like the distance between the Earth and the Sun, these are very, very big numbers. For the small numbers, like the size of an atom or the mass of an electron, these are extremely small. So here it comes the importance of using scientific notation. So the advantages of using scientific notation: it allows the representation of very large or very small numbers using fewer digits. It makes it easier to compare the magnitudes of different numbers, and it simplifies calculations involving very large or small numbers. So we use scientific notations in many ways for making calculation easier and finding the answer easily. So, writing numbers in scientific notation. How to write numbers in scientific notation? We have to follow 3 steps. Step 1, the coefficient. I write a number between 1 and 10, including 1. Okay? 2, exponent. I write it, this number multiplied by a power of 10, indicating the number of places the decimal point has been moved. So the exponent of the power of 10 indicates the number of places the decimal point has been moved. Step 3, multiplication. I multiply this coefficient, this number, by the powers of 10. So writing in scientific notation will be in this form. A times 10 to the power n, where A it's a number between 1 and 10. 1 is included. It means 1, 2, 3, 4, 5, 6, 7, 8, and 9 point something times 10 to the power n. N is the exponent. This indicates how many times do I have to move the decimal point. Let's make an application. Convert the following numbers to scientific notation. Let's look at these numbers. So to write in scientific notation, first of all, I have to write a number from 1 to 9. So take the first number and put the point. This is the first step. So it will be 1.37 times 10 power something. I have to find the exponent. How to find the exponent? I have to put the decimal point here. So 1, 2, 3. Since I move the decimal point 3 steps to the right, I have to put here a negative exponent. So here it will be 1.37. After the first number we put the point, and then I moved the decimal point 1, 2, 3 steps to the right. So I put negative exponent. Now look at the second number. Where should I put the decimal point after the first number? So I should put it here. Okay, here where is the decimal point? It's outside, it's here. So I have to move the decimal point. How many digit? 1, 2, 3, 4 to the left. So it will be 1.5237 times 10 to the power 4. It's positive because I moved the decimal point to the left. Let's look at the second number. Where to put the decimal point? After the first number. So it's here. Where is the decimal point? It's outside. So 1, 2, 3, 4, 5, 6, 7 to the left. I write first the number 5.900005 times 10 to the power positive 7. Okay, I move the decimal point 7 digits to the left. Now this number, it's already here, the decimal point. Where should I put it? After the first number. So it should be here. Let's put it here. So it will be 1.23025. I will move the decimal point 1, 2 digits to the left. So here the exponent will be positive 2. Okay? The last one, similarly, I should put the decimal point after the first digit, behind it. Okay? So here the decimal point should be. So our number will be 5.025 times 10. What is the exponent? Since I will move, this is the original decimal point, I will move it 1, 2, 3, 4, 5 to the right. So it will be negative 5. Okay, so like this we write numbers in scientific notation. By this we finished our session. Thank you for watching. Goodbye.